This is the end of section 4.3 that we didn't get to in class the other day. We've been doing proofs using several different postulates and theorems. So now the one that we need to look at the end of this section is the angle-angle side theorem. It says that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of the other triangle, then the triangles are congruent. So looking at our example triangles that are drawn out, you can see that angle D and angle G are congruent, angle C and angle T are congruent, and then the side that's not in between D and C. Those pairs, well, there are two sides that they could have used, MC or MD, but so they chose MD, so we have to make sure that we get the corresponding side for the other triangle in order to be able to use the angle-angle side theorem. Okay, so let's see a couple of examples of how those are worked out. All right, so in example 3, they give us this figure where there are basically two triangles attached at the bottom, or from P to R. And so we're given that angle S and angle Q are congruent, and also we're given that RP bisects angle SRQ, which is this big bottom angle here at R. And so we're wanting to prove triangle SRP is congruent to triangle QRP, and they asked us to make a plan first for how we could use angle-angle side. So we need to look at our triangle first. We see that the corresponding angles that we're looking at are angle S and angle Q. That's one pair. And in the figure, it's marked that SRP and QRP are congruent. We're going to be able to get that from the fact that RP bisects angle SRQ. So we'll want to state that first. So our plan is to state that angle SRP is congruent to angle QRP. And then after that, we have our two angles. We just need a non-included side. So it can't be side SR and RQ because that would be included. So the side that looks the easiest to use would be the side PR, which is the one that they share, their common side. So I need to, I want to be able to say that PR is congruent to PR. So I've got my two angles, my non-included side, and that would be enough to show that the triangles are congruent. Okay, so now let's see how to write that out in a proof. So of course the first step is always going to be the things that you're given. And again, you can split this up if there's more than one thing if you want to. I prefer to just go ahead and write it all out in one step. Your book normally will write things one at a time, and anything that follows from the given information they would write underneath it in the next step. Okay, so angle S is congruent to angle Q. That's one of our angles, pairs of angles. The second thing we said we needed to do was state that angle SRP was congruent to angle QRP. And I wonder if you can think about why that would be true. We were given that RP bisects SRQ, and the definition of an angle bisector is a ray that cuts a larger angle into two equal pieces. So this would be just the definition of an angle bisector. Oops, spelled that wrong. Now, when you read RP bisects angle SRQ and you see that it's marked in the figure, you might be tempted to just skip saying that these two angles are congruent, but in a proof you have to state everything. Even if it's obvious, you have to go through the motions of actually listing out each pair of angles that's congruent and the non-included side in this case, Every part that you need for your whichever theorem you're using, you have to actually state the angles or the sides or whatever it is you're looking for. Okay, so now we have two of our angles, which is all the angles we need, and then we're going to do use that common side. PR is congruent to PR. And when we say something is congruent to itself, we always use that reflexive property. Oh, well, that word doesn't look right at all. Okay, so now we have our two angles, our non-included sides, so we can go ahead and say that triangle SRP is congruent to triangle SRQ. And that will be by the angle side theorem. Okay, so when you're trying to do these proofs, once we start seeing several of them together, right now they're kind of giving us a certain way they want us to prove it, but you're going to have to be able to look at a figure and find the easiest things you can that you can prove are congruent, and then pick the theorem based on that. Let's do one more additional example for the last part of this section. Okay, so here I have a quadrilateral drawn in, and I'm told that angle B and angle D are congruent. I've marked that in the figure. I'm also told that side AB is parallel to side CD, and I've also marked that with the arrowheads. So again, we want to use the angle side theorem to prove that triangle ABC is congruent to triangle CDA. So I'm going to start with writing down my given information. And my reason is given. Okay, now let's look and kind of make a plan before we start writing things down. I have one set of angles. I know that AB is parallel to CD, and I'm going to need another side. So the question would be, knowing that AB is parallel to CD, how does that help us? It doesn't help us get a side length, but it could help us get an angle. So if you look at these parallel lines and you pretend that the diagonal that's splitting this quadrilateral into two triangles, if you extend that out a little bit, you can see that could be a transversal. And so if this is a transversal going through these parallel lines that I could also extend out so it's easier to see, then this angle at A, BAC, and this angle down here at C, which is CDA, those two angles are alternate interior angles. They're inside the parallel lines, they're on opposite sides of the transversal. And so alternate interior angles are congruent, we know that. So using that parallel lines that are given, that's the next step that I would write down. I would say angle BAC is congruent to angle DCA by alternate interiors angles theorem. Now you're going to find that this is a common problem that they give you, where they will give you some lines that are parallel and you have to figure out which angles are congruent. Many times we're going to use this alternate interiors angles theorem in a figure that looks something like this. So you need to, that's one of the things you could look for that you'd be able to use. As we go through these proofs, over and over we're going to use some of the theorems that we've learned, and so you begin to see what you need to look for. Vertical angles is another one that we use a lot. Reflexive property is another one we use a lot. So as we go through, you'll begin to get familiar with the kinds of postulates and theorems that we're using, and you'll know to look for those things. Okay, so now I have two angles, and if I'm trying to use a non-included side, this could be similar to what we did in the last example. So I could choose the common side that they have, that side AC, and I could say that that's congruent to itself. And what property is that I use? Reflexive property. Okay, now once I have two angles and non-included side, I can write down my proof statement, which is the triangle congruence. So triangle ABC is congruent to triangle CDA, and that was by the angle side. Okay, so I want you to practice the rest of the problems in section 4.3. We're going to be doing some more proof practicing this whole chapter. We'll have a lot of proofs in it, and so you need to become familiar with each type of problem or proof as we're doing them, and try to begin looking for those things that the proofs have in common. All right, thanks.